Hello learners, welcome back to the channel. Today we are going to learn about OOPS concept in Python. So let's start. What is OOP? So OOP is nothing but object oriented programming in simple words. Now let's understand this concept. So imagine you are playing with Lego. Each Lego piece is a small part, right? Like a function or a variable, we can say. But when we combine them in a smart way, then you can build a car, a house, or a robot, or anything. So we can say OOPS, object oriented programming, is like building your code using Lego. You can make blueprints we called class, you can say blueprints as class, and then create real things, which is object from those blueprints. So this is the OOPS concept. Now why OOP? So OOPS is really awesome. If you will use in your programming language, this is like real ease, you can say. So it is reusable. You can write a class once and you can reuse it many times as you want. Like no copy paste madness, like nothing. You just write once the class, and the same class you can use anywhere you want multiple times in your code. Then also you can say this OOPS concept keeps things organized. Like it put related code and data in one place inside a class. So we can say it's neat and easy to manage. Also it's like in real life it's very helpful. Like you can write code the way you think. For example, we can say suppose let's create a dog class, okay, with properties like name and breed and actions like bark. So the you can write the real life things. It is easier to fix and grow. Oops makes your code easier to update or fix or change, like so it's very comfortable to write in OOP using the OOPS concept. So in short we can say that suppose like class is a blueprint or a plan, like a recipe, or any suppose any house you have to make. So first you create a plan that this is how it should look, and then with the same structure, the same design, you can create multiple house, or you have a recipe, so you can use that recipe multiple times, right? So that is a class. And object is when you are actually doing that things, so actual item made from the plan, like suppose from the recipe I cooked cake, so that is, or from the house design we constructed a house. So that house is actual object, and the plan and that structure of the house, design of that house, is a class. So OOPS help you write clean, smart, and real world friendly code. So that's why it's very very important. And I will be explaining everything: class, object, and then all the four pillar of the OOPS concept. Everything I will cover in this video. So let's start. Here I have also given you the simple note, you can say. You can write it down in your notebook as well. So let's start with class. A class is As I have already explained, a class is a blueprint or a template for creating objects. It defines a set of attributes, which is data, and methods, which is functions, that the object created from the class will have. So imagine a car, right? So it defines every car will have a make, model, year, and a start or stop, everything. We can create function and we'll keep everything inside the class, and then we can call this class by giving its attributes, make, model, year, and then you will you can call it, and whenever you want you can call it, and also using its function explicitly, that also you can do. So let's see how to write a class. So very first, there is a keyword to define a class. Very simple. Simply write class and then write the class name whatever you want. So this is how you define a class, and then semicolon. Now inside that you should write whatever you want, any variable you want. So this is the class car I have created, and this colon indicates that start of the class body, semicolon. As you know, in Python everywhere writing function or writing loops or writing conditional statement, we give the semicolon. Here also we give the semicolon, same way, just using the class keyword, and after that you write your class name whatever you want. Here I have written car. Now next is wheels is equal to 4. So this is a class attribute. It is a variable that belong to the class car, and it means that all objects like instance of this car class will share the same wheel variable 4. Like this is a, you can say, global variable, and whatever function I will write inside this car, like start is a function, stop is a function here. So this wheel variable, all of these functions they'll able to use. Now next we are defining the constructor in it, and here I am giving a like self, make, model, and air. So this is a special method, and simply we call it as a constructor. So it's automatically will called whenever a new car object, whenever I will create a actual object from this class, this constructor will automatically get called this in it. But see, this is another function, start and stop, this will not automatically get called, but this is a constructor, right, in it. So this will automatically get called when you will create any object for this class car. So let's see what's inside this constructor. We have three things: make, model, and year, and then we will initialize all the value: self.model, self.make, and self.year. And initially we'll keep self.is running as false. So self is nothing but a reference to the instance of the class being created, and it must be the first parameter of any instance method. So that's why I have written it very first. And next, make, model, year are the parameters that we will pass when we will create any car object, right? Whenever you will create any object through this class, we have to pass, compulsory we have to pass these three parameters: make, model, and year. Now this I have taken self.make is we will be taking an instance attribute named make for the specific car, and object being initialized and assign the value passed to the make parameter. Same way self.model and self.year, it will take and it will assign it here. Now self get dot running, is running is false. So this is a different instance attribute initialized to false. This tricks the car's running status, like this will track the running status of the car. Now next we have method start here. So this method, this is the another instance attribute, sorry, this this is another function define start. So this will take self again, is first parameter, indicating it operates on an instance of the car class. So the logic inside the checks, see here, self is running is right now false, right? So I will be checking here self dot, if not self dot is running, then it means that it is true and it is running, and then we will print it, and or else we will print that it is already running. So this is what the start method will do. Now next we'll have the stop method. So it is similar to start. This method handles stopping the car here. So it will check if self dot is running, means if it is false, so it will say that self dot is running is false, and if it is running it will make it as false, and then it will print that it is stopping, or if it is already stopped, it will say it is already stopped. Now next method we have display info. So this method prints out information about the specific car object, and it will be accessing both instance attributes, this self dot make and self dot model and self dot year, and the class attributes also self dot wheels. Now once you will create here in this class car, I have given the started this wheel global variable, and then wrote the constructor. This will get automatically called whenever you will create any object of car. And then we have three different methods: start, stop, and display info. So whenever you will call this function, uh, uh, after creating the object, you have to call explicitly, you will have to call these functions. Let me show you how. So very first let's learn how to create object of an class. So an object is an instance of a class. So when you create an object, you are creating a concrete entity based on the class blueprint. So right now we have a blueprint, right, for the class car. Now let's call this. So when you are calling, it means you are creating an object. So I'm creating an instance of the car class, my car, and this is the class name car. And as I have already told that when you will be calling this car class, you will have to give three parameters: make, model, and year. So I'm keeping Honda Civic and 2020, and I'll be saving this inside this variable my car. So my car right now, it is an object. It is an object. Okay, so let me just clear out all output so that you will be. So here let's run this. Okay, see, now this is the object. Now let's call this. So I will be calling and saving into this my car. Now accessing instant attributes. See, when I run the class, there's no output. When you will be creating an object and creating an object means simply calling that class and keeping inside this variable. So this will also will not show you anything until unless you will call its function. So simply I'm just for understanding, I have kept here three print function. In the first print I will be printing the make, in the second I will be printing the model, and in the third print I will be printing the year. So these three, Honda, Civic, and 2020, will get printed in all these three. Now accessing the class attribute. So here I will be accessing the my car dot wheels. So this wheel will automatically get called, as you know, we have this is a global variable, so this will get called, and then car dot wheels. Now let's see how to call the instance methods. So we have defined three function in the class, right? That is start, stop, and display info. So all these we will be calling like this. This is how you call the function inside the class. So write the object my car, and then dot, you should write the function name. So first I have written start, the second I have written display info, third stop, and then my car dot display info again to see the updated status. So let's run this. See, my car's make is, first I have what written, my car's make is what, Honda, then model Civic, then year is 2020. My car has four wheels, right? Then all cars have here I have written all cars have four wheels. Then next is the 2020 Honda Civic is starting. Why? Because I have called starting method, start method. Then what, display info. So display info is Honda Civic 2020. Then I'm like wheel, what is the wheel, 4, status is what, running. Then after that I call the stop function, right? So it will say the Honda Civic is stopping because first it was started. So as I have written in the function, if it is started, it will get a stop. Next, again, I asked for display info. So again, it will say car is Honda Civic 2020, wheel is 4, and the status is what, stop, because after starting I stopped it. So this is how you can create object of class and then call the functions from the class. Now let's learn the four pillars of OOPS. So OOPS is often described by its four fundamental principles, which is first one encapsulation, second is inheritance, third polymorphism, and fourth is abstraction. So encapsulation is the bundling of data, attributes, and methods that operate on the data within a single unit. So it also involves restricting direct access to some of an object's components, which is a form of data hiding. So in Python, encapsulation is achieved by convention. While Python doesn't have strict private keywords like some other languages like Java and all, we use conventions. So public is attributes and methods accessible from anywhere. By default, you can, if it is public, you can use anywhere. Protected, it means attributes, methods prefixed with a single underscore. So if any methods is prefixed with underscore, it means this is a convection, this is a convention indicating they should not be accessed directly from outside the class or its subclass. And then private is will be prefixed with double score. It means Python performs name mangling on these, making them harder. You can obviously call it, but not from outside. This is primarily to avoid naming conflicts in inheritance, like in other concept as well. So this is the three things we will be using: public, protected, and private in all these concepts: encapsulation, inheritance, polymorphism, and abstraction. So let's see what is encapsulation. So generally these four concepts is to make your data more safe, and generally when you write any code for in production, and it should be deployed or then you must use all these four concepts, because this will make your data more safe, more protected. Okay, so let's see encapsulation. So as I already told, encapsulation means it is a bundling of data and methods that operates on the data within a single unit. So this is like here I have written deposit function, withdraw function, and then get balance, and everything is what inside this bank account class. So again, same thing, this is the bank account class I have defined, and then this is the constructor. So whenever you will create any object, this constructor will automatically get called. Now this deposit and withdraw function and get balance function, you have to explicitly call upon that object. So here very first, whenever this bank account class you will create, you will have to give two things, account holder and initial balance, and then it will get initialized. After that, I have written function deposit. So this deposit function will take self as a parameter and amount, and if amount is greater than 0, it will add the amount to the balance, and it will show you the print message. And in withdraw, same thing, it will take self and amount, and if it is amount is greater than 0 and self dot balance is also greater than amount, then obviously you can withdraw it. Otherwise it will show you a pop-up that withdrawal amount must be positive, and else it will show you insufficient funds. If the amount is less than 0, it will show like this, and if the amount is insufficient, it will say insufficient funds. Next method we have get balance. So it will simply result what, the balance, self dot balance. So this is a public method to access private balance. Now uses again, I will be creating a object. This is what object account I have created, and call the bank account class, and pass the parameter Alice and 1000. And after that, on using this object, I will be calling all the three functions: deposit, withdraw. So let me just run this. See, now deposited $500, new balance is this. When you withdraw, see, 200, and then again if you will withdraw 500, it said insufficient funds. And next, current balance, here I have shown, so it is showing the current balance. And then last again I'm showing the bank account balance, so it is showing 1300. So this is the encapsulation. You write everything inside a class and then using it after creating the object of it. Now inheritance. Inheritance is a mechanism that allows a new class or a subclass or child class to inherit attributes and methods from an existing class, which is a superclass or parent class, we can say. So this promotes a code reusability and establish and is a relationship. Suppose dog is a mammal. So let's understand this. So very first I am writing here class animal. So this is a parent class for us. I have wrote constructor and passing the parameter name and species, and then initializing both of them, self dot name, self dot species. And now I'm creating a function here inside this parent class, which is make sound. Now as uh, like here I show that it allows a new class to inherit the properties from its parent. So suppose here I am writing a new class, class dog, then another class cat. Now if I will use the inheritance properties, it means this class dog can use this function make sound. So make sound is what, this class properties, right, this animal class property. But by using inheritance, you can use this function make sound in different class, in child this dog class or this cat class. So how to use that inheritance property? So inside, when you define class dog, you have to pass this class name animal. So this is how child class inheriting the properties from the parent class animal. And here also in the class cat I have written animals, which means another child class inheriting from animal. So this way this animal will become parent class and this cat class will become the child class. Now again same way, I after inheriting the property I'm writing a constructor, and in the constructor I'm passing two parameters, name and breed. Self is the first parameter, it is by default. So after that I'm just calling super dot initialize in it and name species dog and call the parents constructor. Here I have called by using the super, I have called the this uh, constructor, and I'm writing self dot breed is breed, and then I'm just override. You can also override parents method. So here I'm using define make sound self, and I'm keeping as print oof oof. Now there is a another method print fetch, define fetch. So this is a new method specific to only dog, this dog class. This method you this is only its own dog class method, and simply I'm writing a print statement here. Now same way in the cat, again I'm using the uh, animal constructor, animal class constructor here, super dot initialized and then species as cat, and then I'm just keeping this self dot color is color, and then I'm calling override the parents method and printing meow. So how to call all these? So simply again we will be creating an object. So I'm creating an object for animal, and I'm passing the animal class and passing two parameters, generic and unknown. Now again I'm calling the dog uh, this class and cat class, and here I will be passing the parameter buddy, golden retriever, whiskers and tabby. Now here I have created only object, right, with parameters. Now let's call the function. So as animal dot make sound, right, this object can call dot make sound function. This dog object can also, this can also call dot make sound. Why? Because we have inherited the properties, right? So make sound is inside this class animal, but we can call here dot make sound, and then also dog has another function fetch, so I'm calling that function also fetch, and I'm keeping the parameter as ball, and then I'm calling again cat dot make sound, and in the last I'm printing dog name is this and the breed is this. So let me just run this. Okay, see some generic animal sound. This is what, this is coming from the parent class, some generic animal sound. Now next is woof woof. Why? Because here I have again override the parents method and I am printing woof woof, and here also I have in a cat method also I have override the parents method, which is new. So this is how the inheritance works. Now next is polymorphism. So polymorphism means many forms. Polymorphism allows objects of different classes to be treated as object of a common type. So it often works hand in hand with inheritance. Suppose if dog and cat both inherit from animal and override make sound, you can call make sound on any animal object or its subclasses and get the appropriate behavior. So let me show you here. Define animal action, and I am what? I am inheriting the properties of animal object, and so this is a doc string I have written. This function demonstrates polymorphism. It can accept any object that has a make sound method. So now I'm calling animal dot make sound. Now this you can call anywhere, like I'm calling this uses with inherited class. So I'm calling animal action and with first with the parent class Leo and lion, then second with dog, and third with cat. Now let's see with a non-inherited class how the polymorphism works. So this happens like here I am not inheriting any properties in the class robot, and simply I have written make sound self and print beep beep. So when you will create object for the class robot, and if you will call animal action robot, it works because robot also has a make sound method, right? So let me just run this and see. Everything it is showing correct. Some generic animal sound, woof woof, meow, beep beep, right? So polymorphism allow objects of different classes, right? Allow objects of different classes, right? Different class animal, different class dog, different class cat, and then also different class robot to be treated as objects of a common type, right? So this is a polymorphism. Now the fourth is abstraction. So abstraction is the concept of showing only essential information and hiding the complex implementation details. So it focuses on what an object does rather than how it does, right? So in Python, abstraction is often achieved using abstract classes and methods from the any module, from the ABC module, or simply by designing interface. So here there is one module ABC, small ABC. So here you can write from ABC import capital ABC and abstract method, and then I will be creating classes. So we have class vehicle. So like class vehicle is we define vehicle as an abstract base class by inheriting from capital ABC, right? Here I have written that the capital ABC. So this is abstract base class. So this means you cannot directly create an object of vehicle, and I have initialized the value taking the parameter self and brand, and then initialize the value of it. Now at the rate abstract method, here you see, right? So this decorator in Python, whenever we use this at the rate and then any method name, so it becomes a decorator. So this decorator marks start engine and stop engine, all these. Here also I have used decorator abstract method. Here also before this function stop method also I have used decorator abstract method. So uh, any concrete subclass of vehicle must provide an implementation for these methods, otherwise it will also be considered an abstract class. So simply I have just written a function, and so it is this decorator uh, when you will write the decorator above any function, this function can use the property of this method, abstract method. So that's why we use the decorator. Now this stop engine method can use the properties of this abstract method. So simply I have not written anything, I'm passing it in abstract method. Pass we use as placeholder because there is no default implementation, like I haven't written anything. Now we have this class car vehicle. So this is concrete class implementation vehicle. So it is a concrete subclass that implements start engine and stop engine. Now next we have this electric car vehicle, right? here. So this is another concrete class complete implementing. This is another concrete subclass, we can say, with its own implementation. So let me just show you the example that here. So how to create the, we can create car and electric car objects, but attempting to create a vehicle object directly would result in a type error, because this enforces the abstraction. So you interact with a specific type of vehicles, not a generic unimplemented vehicle, right? So see here, I'm writing my car, and then my electric car, and then my car dot display, and then dot start engine. So let me just run this, and then you will understand. See, it is showing you vehicle brand Ford, and then this is Ford Focus engine starts with a key. Vehicle brand is Tesla. Here I have given, and then the Tesla electric car silently powers on. Like whatever I have written. So this is how you can implement the abstraction in Python. Now there's some special methods, that dunder methods. So Python classes have many special methods. You can say it as dunder methods because they start and end with double underscore. Like see, in it also double underscore we started and ending. So these methods allow your objects to interact with built-in Python functions and operators in a consistent way, right? So here init str, so let me just show you. Init str, uh, a representation, repr, len, add, all these. So let me just tell you that, see, this is a constructor, and I have already told you before, automatically it will get called. Then str, it defines the string representation of an object when str is called or when the object is printed. Then repr, so this defines the official string representation used mainly for debugging and development. Then we have len, defines the behavior of the len function, length function. And then add is defines the behavior of the plus operator. So let me just run this, and I also created the object. So let me just run this here and see, it is showing you book1. So I'm calling this book class, and I have passed the parameter. Here I'm in the book class, I'm passing title, author, and pages. The three parameters I have passed: title, author, and this pages. And then for the next another object I created, and with different parameters. And this is how you use print book1, then print repr book1, print length of book1. So here length of book1, it only showed you length. Book1 plus book2 pages, so it has added the pages, and it has shown you. So this is how you can use the different functions, methods in special methods in Python classes. So that's it for the OOPS concept. I hope you like the session. If you have any doubt, write in the comment section.